Alright, distance and midpoint. Let's say you just have a horizontal line. How would you find the distance? Well, you could just say that's 1, 2, 3, 4 units. Well, that's pretty easy. Or if you had a line that was going straight up and down, then you could just count there that you have 1, 2, 3, 4, 5 units. So if it's horizontal or vertical, yeah, it's a no-brainer, but what if you have a diagonal? If you have a diagonal that looks like that, that's not as easy. Alright, well, distance is simply making a right triangle and using the Pythagorean theorem to solve for C. So the rise and run are the legs A and B. So look at our last, that diagonal that I drew, and I said, how would you find that distance? Well, you can't just say 1, 2, 3, because that doesn't work for diagonals, but what you can do is make a right triangle out of it. So there's my rise and my run, and notice that I have a right angle. So then this is 1 unit, and that is 1, 2, 3 units up, and those are my A's and my B's. And then that is my C. So that one would just be 3 squared plus 1 squared equals C squared. So it's 9 plus 1 equals C squared. So it would just be 10 equals C squared. And it's just the square root of 10. So just make a right triangle out of it. Alright, why don't you jot one down with me? Alright, so example 1 is find the distance between 2, -3 and 5, 1. Well, the easiest way is to use graph paper. So we're going to graph each of these ordered pairs. So 2, -3 is right 2 down 3, so right about there. And 5, 1 is right 5, 2, 3, 4, 5, up 1. So right there. And I'm going to connect them like that. So I've graphed it, and I just need to make a right triangle. So I can use my rise and my run to do that. So I'm going to draw my rise here from this point, and then my run. And notice I just made a right triangle. Alright, now that you've done that with me, let's go ahead and count how tall it is. So the rise is up 1, 2, 3, 4. So I'm going to label this side 4 units. And then the run is over 1, 2, 3. I'm going to label that 3. And remember what we said up here? We said we're solving for C, so that's our hypotenuse there. So I'm just going to label those letters so there's no question. I'm solving for C, and it says that I'm given the rise and the run, which are the legs, my A and B. Remember, those are your smaller sides. So A and B go here. It doesn't matter which one's A and which one's B. And now we just have Pythagorean theorem. So I'm going to write A squared plus B squared equals C squared. And I'm just going to plug in my numbers. So my A is 4 squared plus my B is 3 squared. And I'm trying to find the C. That's my distance. So C squared. And then 4 squared is 4 times 4, which is 16. Plus 3 squared. 3 times 3 is 9. And add those up, we get 25. And our last step, the inverse of squaring something is taking the square root. So let's square root both sides. Whatever you do to one side, do to the other. Square root of 25. What times itself gives us 25? That would be 5. So 5 is C. And you can always double check your C. That distance should always be greater than the 2 legs that you started with, the 3 and the 4. Alright, now that's not the only way to do it. I do want to show you another way. It's always good to know more than one way to do something. Alright, so let's say that you don't have graph paper. So without graphing, you can just use the rise and the run. And remember where we heard those terms? Yeah, when we find the slope. So it's where the rise equals y2 minus y1 and the run equals x2 minus x1. So look at that example we just did. We calculated the rise was 4, the run was 3. But what if we didn't graph it? Well, we would label our ordered pairs. So let's try that one without graphing. So 2, negative 3, and 5, 1. And I'm sure after doing it both ways, you'll probably prefer the graphing method, but that's your call. Remember, the first one's x, this next one's y, x and then y, and you get to pick which one's your first ordered pair. I'm just going to choose this one's my first one, which means the other one is my second ordered pair. And your formula looks like this. It's the distance equals, and it's really the same formula. You're just squaring the rise, just like you're squaring a, and adding it to your run squared, just like you're squaring the b. And then the last step is to take the square root. So these are the same steps as Pythagorean theorem. They're just written a little bit differently. So just think it's a squared plus b squared, and then your last step is to take the square root. So I'm going to plug those guys in. My rise would be y2 minus y1, so that would be 1 minus negative 3. And 1 minus negative 3 is really 1 plus 3. And then for my run, it's x2 minus x1, so it's 5 minus 2. Squared. And I bring everything else down. So the next step is 1 plus 3 is 4 squared. And it doesn't matter if this is a negative number or a positive number. When I square it, it's always going to be positive. Okay, so 5 minus 2 gives me 3 there. And then when I square them, square 4 I get 16, square 3 I get 9. Boy, those numbers look familiar, don't they? That's what we just did up above. Remember, we had the 16 and the 9 up there. So here we go, let's finish it out. So we have d equals the square root of 25, and then what times itself gives us 25? That would be 5. So d just equals 5. So again, this is the same thing, just written a little differently. I definitely think the graphing is probably easier. It's definitely more visual. But both of them are essentially using Pythagorean theorem. Alright, let's apply what we've learned. We're going to find the perimeter of a triangle. So here we are. Alright, so example 2, find the perimeter of a triangle with points at negative 3, 5. So I'm going to go left 3 and up 5. And 2, 3, right 2 and up 3. And then 1, negative 2, right 1 and down 2. And I'm going to connect these because I know it's a triangle. And what did we learn? Well, I know what perimeter means. Perimeter means the length all the way around this figure. So basically what I'm going to do is I'm going to find the length of all three and add them together. So that's a key word. And I'm going to set each of these into right triangles. So for instance, I could do rise over run. There's my right triangle. And how much does that rise there? 2. How much does it run? 1, 2, 3, 4, 5 units. That's 5 units across. So off to the side, I'm going to do Pythagorean theorem to find this side right here. So 5 squared plus 2 squared equals c squared. And that means 25 plus 4 equals c squared. So 29 equals c squared. And I take the square root for my last step to get rid of that squared. And it would just be the square root of 29. And I can find that as a decimal a little later. Alright, so I have that one down. Let's do another side length. So I'm going to do this side next. So to get from here to here, I'm just going to make it a right triangle. So I have my rise and my run. And I'm going to write down what my run is. 1, 2, 3, 4 units. And then my rise is 1, 2, 3, 4, 5, 6, 7 units. And that's my right triangle there. So then I'm trying to find this side, that's my C. So I just do a squared plus b squared equals c squared, so it's 7 squared plus 4 squared equals c squared. 7 squared is 49, 4 squared is 16. I add them together and I get 65 equals c squared. And my last step is to take the square root. So c equals the square root of 65. Alright, I have 2 of my sides down. I just need 1 more to go. So I'm going to make a right triangle right here. And this one's a little hard to see because of the way I drew my line. But it's a real skinny right triangle there. And there's my right angle right there at the bottom. So bear with my picture there, but it's only 1 unit across, and it's 1, 2, 3, 4, 5 units up. And those are my legs, so I'm going to do 1 squared plus 5 squared equals c squared. So 1 squared is 1, 5 squared is 25. Add them up, we get 26. And the inverse of squaring is square root. So the square root of 26 is my c. Okay, so now that I have my 3 sides, I'm just going to add them all together. So square root of 65 plus the square root of 29 plus the square root of 26 will give me my capital P, or perimeter. So I know the square root of 65 is about 8.1 because I typed it in my calculator. And I also know it's about 8.1 because 8 squared is 64. And that's really close to 64. It's just barely above it. And square root of 29, that's a little over 5. And to be exact, that would be about 5.4. And same thing with square root of 26. It's a little bit more than 5. Because 5 squared is 25. So that's about 5.1. Equals my perimeter. And then I'm going to want to add those 3 numbers together. And I get 18.6 units is my perimeter, and that's my answer. So perimeter is just the distance formula, in this case 3 times in a row, added together. Alright, I think we've done really well on distance, so now let's jump over to midpoint. And midpoint is exactly what it sounds like. So midpoint's the halfway point between 2 ordered pairs. And you just write the average of the x's and the average of the y's as an ordered pair. That's all there is to it. So for example, let's say we wanted the midpoint of 2 ordered pairs, and let's say those ordered pairs are -6, 8 and 2, -5. Well, if I just find I'm going to label these, so that's my x and my y, my x and my y. So I'm just finding the average of them. Well, what does average mean? It means you add them up and divide by how many numbers you have. Well, how many x's do you have? 1, 2. So I'm going to do -6 plus 2 and divide it by 2 since I have 2 of them. I'm going to write it as an ordered pair, so I'm going to write a comma next to that. I'm going to put this all in parentheses, just like an ordered pair is. And now I'm going to do it for the other one. So the other one is, I have two y's, so 8 plus negative 5, I'm just adding them up. And then I have two of them, so I divide by 2. And now I'm just going to simplify that. So negative 6 plus 2 is negative 4 over 2. 8 plus negative 5 is 3 over 2. And negative 4 divided by 2 is negative 2. 3 divided by 2 is 1.5. And I'm done. So it's that simple. Just find the average of the x's, the average of the y's, and write them as an ordered pair. So the formula looks like this for midpoint. And it is important that you jot this down, but I've already talked about what it means. So x1 plus x2 divided by 2, comma, y1 plus y2 divided by 2. And that's all there is to the midpoint formula. But sometimes you'll be given the midpoint and an endpoint, and that formula might be a little more constructive or easier to implement. All right, that wraps it up. All right, time to measure some distances.